All right, this is from the 2007 AP test. This is the polar question. They gave us two different curves. Our first curve is r is equal to 2, and we know that that's our circle right here. And the next curve they gave us was this cardioid, which looks like this. They told us the intersection points of each of these. They intersect at 2 pi over 3 and 4 pi over 3. And we need to find the common area. First, remember that the area for polar is 1/2 the integral of r squared d theta. So you imagine cutting your theta wedges. So if I start at 0, I'm going to be going to the circle. I'm going to keep cutting the theta wedges to my circle until we get to 2 pi over 3. So 1/2 the integral from 0 to 2 pi over 3 of the circle squared d theta. And at that point, we're going to switch to the cardioid. So right here, we're now going to the cardioid. And I can stop there and use symmetry, multiply by 2, or I can go all the way down over here. So again, I'm going to have 1/2 the integral from 2 pi over 3 to 4 pi over 3 of 3 plus 2 cosine theta squared, quantity squared. Now on the first one, notice that I'm still missing part of my curve. I haven't found this right here, but that area is going to be exactly the same as the orange area, so I'm just going to multiply that by 2. We put this in our calculator, and we find that the total area works out to be 10.370. When you put it in your calculator, leave it in Cartesian XY rectangular coordinates. Do not move it over to polar. Part B. A particle is moving with a non-zero velocity on the cardioid, and between theta equals 0 when t equals 0, we know that dr dt is equal to dr d theta. We want to find dr dt at theta equals pi over 3. Okay, so here, part B, we're using our cardioid. So r is equal to 3 plus 2 cosine theta. They want us to find dr dt, but they told us that's the same thing as dr d theta, which would be minus 2 sine theta, and we're going to evaluate this at pi over 3. So dr dt at pi over 3 is negative 2 sine of pi over 3, which is root 3 over 2. So that would be negative root 3. And it wants to know what that means on the particle motion. So since this is negative, dr dt is less than 0, the graph is moving towards the origin. Part C, we know that dy dt is the same thing as dy d theta, and they want you to find dy dt at theta equals pi over 3. So for part C, again, we're going to use the same cardioid, but now we're talking about y. Remember that y is the same thing as r sine theta. So for us, it's going to be 3 plus 2 cosine theta times sine theta. We want to find dy d theta, which is the same thing as dy dt. So I'm going to do a product rule here, derivative of the first piece, copy down the second piece, plus the derivative of the second piece, copy down the first piece. And then we want to evaluate this at, again, pi over 3. So minus 2 sine of pi over 3 is root 3 over 2. So root 3 over 2 squared. The cosine of pi over 3 is 1/2. So this leaves us with negative 2 times 3 over 4 plus, this works out to be 4 inside there, so plus 2, which would now be negative 3/2 plus 2. I know this is greater than 0. Since this is greater than 0, we know our particle is moving up. So since dy dt is greater than 0 at theta equals pi over 3, the graph is moving up or away from the x-axis. Okay, so how is this scored? Part A is worth 4 points. 1 for the area of this circular region, so this piece right here. 1 for the integrand inside the cardioid, and then 1 point for the limits and constant, and then 1 point for the answer. Part B is worth 2 points. 1 for finding dRdt, and 1 for talking about the motion of the graph. Part C is also worth 3 points. First, for the expression in terms of for y, you can either write either of these are acceptable, but they need to know that you were using r sine theta to convert it to y. Then you get 1 point for the derivative value, and then 1 point for the explanation.